Question 6. Refer to figure 1.4. We are given 3-point charge of equal magnitude but placed at the corner of a square of side length D as shown in figure 1.4. So the side is D, this one also D. So Q1 is negative Q, Q2 is negative Q, Q3 is a positive charge of positive Q. So the magnitude of the charge is the same for the three charges. So A, sketch the electric field strength diagram at point P due to the three charges. So we want to sketch the electric field strength created by this 3-point charge at point P. So at point P ni, there will be electric field created by Q1, there will be electric field created by Q2, and also there will be electric field created by Q3. So we want to sketch the electric field strength created by all these three charges. So always use or apply the concept. For charge positive, the electric field line is outward. For charge negative, the electric field line is inward. So kita boleh cuba sketchkan dia. So Q1 is negative charge. So negative charge electric field line akan masuk ke dalam charge. Masuk dari mana? Masuk dari titik P lah yang kita nak lukis. So this one will be E1. Okay. Then for Q2, Q2 is negative charge also. So the electric field will inward. So electric field will be inward. Inward dari mana? Dari titik P lah. Masuk ke dalam charge Q2. So we are going to have this electric field will be inward. Masuk ke dalam charge Q2. So this one will be E2. And then we also have electric field created by Q3. So Q3 is charge positive. So charge positive, for charge positive, electric field line will be outward. Outward. So keluar dari charge Q3. So keluar dari charge Q3. So keluar dari charge Q3. So dia akan lalu titik P pergi ke sebelah kiri. So this one is E3. Okay, dari sini ya, keluar dari charge Q3, hala pergi ke titik P. So E3. Okay, so this is the 3 electric field vector lah at point P. So teacher redraw the diagram. So we have this one. Okay, so kita ada 3 vektor, E1, E2 and also E3. We have done with question A. We have sketched the electric field strength at point P. Then question B, determine the magnitude of the net electric field vector at point P due to the 3 charges if the Q is 2 microcoulomb and D is 3 centimeter. Okay, so since D is 3 cm, so I know that the distance of point P from charge Q1 is 3 cm lah. Then the distance of point P from charge Q3 is also 3 cm. But then for the distance from point P to charge Q2, that one we have to calculate lah using the theorem Pythagoras. So the distance between the point charge Q2 with point P will be D squared plus D squared then square root lah. Because it's a right triangle. Teacher redraw dekat sini . So ini point P, ini charge Q2. So sini distance dia D, sini D. So ini ialah hypotenuse. So gunakan theorem Pythagoras lah. Jadi D squared plus opposite kuasa 2, adjacent kuasa 2, punca kuasa. Okay. So the hypotenuse will be 4.24 to the power of negative 2 meter. So this one will be the distance between charge 2 with point P. Clear? And then we proceed. Okay, so E2, if we refer to the electric field vector that we draw, we can see obviously E1 has only y component. So E1 have only y component. E2 will be act at a certain angle theta. So E2 is acting at certain angle theta. This angle theta can be calculated using the right triangle also lah. The right triangle. So I might use shift tangent. We might use shift tangent. So d over d. D is 3 to the power of negative 2 divided by 3 to the power of negative 2. So I'll get the angle will be 45 degree lah. So the angle here will be 45 degree. Okay. So before we can solve the question to determine the net electric field strength at point P, we have to calculate the electric field at point P due to each of the point charged individually. Okay. So we apply the equation for electric field strength KQ over R squared. We determine the magnitude of the electric field created by charge 1. So we have KQ over R squared. So the R here will be the distance between the charge 1 and point P lah. So K is 9 to the power of 9. Q is 2 to the power of negative 6. The distance in between point P and charge Q1 is 3 to the power of negative 2 squared. So we get the E1 is 2 to the power of 7 Newton per Coulomb. Then we determine E2. The magnitude of E2 will be KQ over the distance between charge 2 and point P squared. So put in the value. So the distance between point 2 and charge P is 4.24 to the power of negative 2. So we get E2 is 1 to the power of 1 to the power of 7 Newton per Coulomb. Then we calculate E3. E3 will be KQ over R squared. The R will be the distance between charge 3 and point P lah. So put in the value also, then we can calculate the value of E3. E3 will be 2 to the power of 7 Newton per Coulomb. Okay, after we have calculated the magnitude for each of the electric field created by each of the point charge, then only we can calculate the electric field, the net electric field at point P. So how we are going to calculate the net electric field at point P? So because electric field is a vector quantity, so we have to do the vector summation. So we have to resolve the vectors. So resolvekan vectors to E1, so refer to the vector diagram we draw. E1, we do not have any component x. So E1 is a long component, only have y component, so 2 to the power of 7. Then E2 we have both component x and component y. Okay, kita tengok balik gambar dia. Ni E2. So E2 ni kita perlu resolvekan dia. So E2 ni ada dua komponen. E2x, whereby E2x is E2 cos theta. Then E2y, we also have y component. E2y will be E2 sin theta. Okay, kita resolvekan E2 kepada komponen X and komponen Y. So, put in the value. So E2 will be 1 to the power of 7 sine 45 and 1 to the power of 7 cos 45 for the Y component. E3, kalau you perhatikan E3, vector E3, so E3 we only have negative X component. We only have negative X component. So we have this one. Negative 2 to the power of 7. Component Y is 0. Okay. Then we do the summation for component X and also component Y. I repeat. Then only we can do the summation along component X and also component Y. So total up the component X, we get negative 1.293 to the power of 7. Total up the component Y, we get 2.707 to the power of 7. Okay, so we will find out that at point P, we will have a net electric field along component X of value negative 1.293 to the power of 7. Along component Y is positive 2.707 to the power of 7. Okay, so we can find the resultant by combining the summation along x-axis and also summation along y-axis. So we will get the net electric field at point P, EP. So the net electric field or the total resultant electric field at point P will equal to the summation of component X squared plus summation of component Y squared square root. Okay, so kita cari magnitude dia, we will get 2.999 to the power of 7 Newton per Coulomb. Okay, so since the question just asks us to determine the magnitude, jadi jawapannya ialah yang ni lah. So this one will be our answer lah. Tapi since E adalah vector quantity, so mungkin kita nak tahu juga direction dia. Apa arah untuk kita punya net electric field at point P? So how we find the direction? So the direction will be shift tangent total E along y-axis divide by total E along x-axis lah. Maksudnya opposite bahagi adjacent, kita dapat theta. So we have tangent, shift tangent 2.707 to the power of 7 divide by 1.293 to the power of 7. So when I do calculation, I'll get the angle will be how much? Around 64.46 degree above negative x, above negative x axis. Okay, if we want to calculate the direction, so this one will be the direction and this one will be the magnitude. Okay, so this is the magnitude and this is the directions. Okay, since it's a vector quantities kan, sebab electric field strength is a vector quantities, it have magnitude and directions. Now we have solved question 6. Okay, we have solved question 6. So after this, please try to solve questions 5 and also question 8. Okay, you might try and solve the question 5 and question 8 that related to learning outcome 1.2 electric field.